All right. So if we look at the chapter 8, and we're looking at that chapter 8 Excel sheet. Okay. So remember, we found it under chapter 8 handout Excel. And we're starting to look at the net present value and internal rate of return when we have mutually exclusive projects. So one of the things that we looked at that I forgot to record was, if you look back at sheet 1, you can see that we have a couple examples that talk about how to find this crossover discount rate, which we'll do again. Okay. But the crossover discount rate is found by taking the difference between project A cash flows and project B. It doesn't matter if you do B minus A or A minus B. If you subtract out the difference, then solve for the IRR of the difference, you can find the point at which the projects cross over. Okay. And if you look at this, it's called a net present value profile. If you look at the net present value profile, you can see where B is better than A and where A is better than B in terms of net present value. I forgot to record that part. All right. So let's go ahead and look at, and we'll do this more realistic example, but it's a little bit trickier. Okay. Not much, but a little bit. Okay. If we look at these two projects, A and B, okay, we're going to notice some interesting things about them. Okay. So this is the idea that if you had a boss come to you and say, hey, okay, we want you to come up with your best idea. Okay. And someone says, well, and again, we're going to assume the projects are equally risky. Okay. We're going to use something called a weighted average cost of capital. Okay. We don't know this yet, but we'll figure out later. That's the appropriate discount rate. So it has a special name. And we'll learn about it in a later chapter. There's lots of different things with capital budgeting. So we're kind of stuck right now on using the tools. So if we look, someone came up with this idea, and I don't know what it is. I just call it Project X. Project X costs $25,000. It's expected to return $10,000 in year 1, $13,000 in year 2, $10,000 in year 3, and $8,000 in year 4. Someone else had another idea, and their idea cost a little bit more money up front, $40,000, but it returned $8,000, $9,000, $25,000, and $30,000. Okay. So if we were going to go through and analyze X versus Y and talk about the advantages of X versus the advantages of Y and which one's better, okay, there's a few tools that we know we can use, but we need to interpret what they mean. Okay. So the 10% is going to be used for both of these projects. Okay. So the first thing we might want to do, since we know how to find it, is let's find the net present value. Okay. And the net present value for A would be 7,000. This drives me crazy. Hold on. I did it myself, but I'm going to get rid of all these pennies. No one puts pennies. You shouldn't really put pennies on a big spreadsheet. Because pennies are unimportant. Now, decimal places are important, but pennies are not important. All right, here we go. All right, so project X costs 25,000, project Y costs 40. They have some differences in terms of what they return over different points in time. But here's some of the things that we need to look at, okay? If we just did only one analysis, okay? We only did net present value. If we only did net present value, oops, not like that. If we only did net present value, then project X would have a net present value of 7,812. Project Y would have a net present value of 14,000 almost. So 8,000 versus 14,000. So if you just looked at net present value, if you just looked at the NPV, oops. Then you'd probably go with project Y. Okay. Project Y has a higher net present value, okay, and therefore makes it more desirable. Okay. But what else can we look at? Okay. Well, we knew how to calculate IRR. Okay. And if we calculate IRR, okay, this one got messed up somehow. Hold on, stop sharing. All right, if we go back and look, oops, now I think. So project Y's main advantage was that it had a higher net present value. Okay. But if we look at the IRR, we calculate the internal rate of return. Notice project X has a higher IRR. So that might be able to tell us something. Okay. Now, some of the other things that we'll notice is let's look at the payback period. If we look at the payback period, it's not $2, by the way. All right. So if we look at it, okay, the payback period's about 2.2 years for project X. How do we calculate that? Remember, oops, all my stuff got erased. All right, higher net present value, higher IRR. Okay. Notice some of the other things. look at project X's payback period. Okay. So remember, we spent $25,000 in year 0. We got back $15,000 in year 1. We got back, oh, excuse me, not 15,000, excuse me. We got back 10,000 in year 1, 13,000 in year 2, and 10,000 in year 3. And we got 8,000 in year 4, but for payback purposes, we don't need to worry about it. Okay. So when does this project get paid back? Well, after 2 years, we got most of our money back. We got $23,000 back relative to our 25,000. So it's 2 years plus the amount that we're short, which is $2,000, divided by what we received during year 3, which is $10,000. So the payback period is 2.2 years. Okay. So remember, we can now kind of see higher net present value, okay, higher IRR. We calculated the payback period as 2.2 years, okay, for project X. If you go ahead and calculate it for project Y, remember we started out with 40,000 was our upfront cost. We get back 8,000 in year 1, 9,000 in year 2. So, but after 2 years, we have 17,000. In year 3, we got 25,000. Okay. But we were short about $23,000 after 2 years. So our full recovery is sometime after year 2, but before year 3. So it's 2 years plus what we're short, 23,000, versus what we get in year 3 at 25,000. And so about 2.92 years. Yeah. So if you look at this closely, you can kind of see, hey, in terms of the payback, and if we wanted to, the book doesn't do this, but you could use discounted cash flows and calculate something called a discounted payback. And one of the advantages that Project X has is that it has a shorter payback period. And the shorter payback period is advantageous because shorter payback provides liquidity, meaning you're getting your money back sooner, but also is an indicator of less risk. Because predicting what will happen farther into the future is a lot harder than predicting what will happen closer in the future. Yeah. So it's kind of like saying, hey, who do we think might win the, if we ever have sporting events again, but who might win like the World Series this year? Okay. Well, it might be a little easier to predict than who will win it 5 years from now. Okay. So the shorter payback period is an indication of higher liquidity and less risk. So we start looking and we can kind of see that Project Y does provide the most net benefit. And after all, after we've paid back the 40,000, we've got about $14,000 left over. That's what net present value is telling you. Okay. You spent 40,000, but you got the 40,000 back plus the interest on the money. And then everything else that's left over in today's dollars is worth about $14,000. Okay. So would you rather have 14,000 more than you started with, or 8,000 more than you started with? Okay. And Project Y's main advantage is that it has a higher net present value. Okay. And so that tells us something about the desirability. Okay. But as we look closer, we can see Project X does have some advantages. It has a shorter payback. You can kind of see most of the cash flows are coming sooner rather than later. And it has a higher IRR. A higher IRR becomes more desirable, okay, because it tells us something about higher IRR means it's less risky. And really what it means is it gives us a greater margin of error. So a higher IRR provides a greater margin of error. Okay. So it turns out if our estimates are wrong, Project A is a little bit safer. Okay. From uncertainty, because it has the higher IRR. Okay. The shorter payback period also means it's less risky. So both of these are indicating factors of risk. The shorter payback is usually also associated with greater liquidity. So now it's a little bit tougher to choose between X and Y because they both have their advantages. Now, one thing we could look at is a net present value profile. So let's go ahead and clear all that. And I'll see if it lets me. So we can look at a net present value profile. And remember I said 10%. 10% was the cost of capital we were using. Okay. And we can see from this, if we look at, okay, this is Project Y. In the maroon, and this is Project X. Okay. And we can see that Project Y has a steeper curve. Project X has a little flatter curve. Has to do with the timing of the cash flows and the impact of changes in interest rates on those cash flows. So really just from net present value, you can kind of tell, hey, Project Y is more desirable just from a net present value perspective up until the point where these cross over. Now the question is, just by looking at the chart, we can kind of see they cross over somewhere around 20%. Probably a little bit less than that. Okay. So that a discount rate of less than 20%, Project Y is more desirable. But as you increase the discount rate, then Project X becomes more desirable. Okay. But actually Project Y becomes negative. So if you were looking for the crossover rate and you wanted to find it, I'm going to go ahead and write it out. Okay, then I'll type it out. Okay. But we want to look at the difference between X and Y. Okay. So it doesn't really matter if you do Y minus X or X minus Y. Okay. But if I did Y minus X, Negative 40 minus 25 is negative 15,000. 8,000 minus 10,000 is negative 2,000. And 9,000 minus 13,000 is negative 4,000. 25,000 minus 10,000 is 15,000. And 30,000 minus 8,000 is 22,000. Okay. So then I find the internal rate of return of the difference in these cash flows. Okay, so these are the y minus x differences. And then I'll go in here and type IRR of the difference between these cash flows, or you can use your calculator. And you can see that the difference in these cash flows has an IRR around 20%. It's actually 19.7. So if you look at this 19.7, that's the difference between the two cash flows up here. This is y minus x. And then I calculate the IRR of the difference, and that will give me the crossover rate. So by looking at this net present value profile, I can kind of look and see some of the differences between y and x. Yeah. Now, if we go back up top, and we go back up top, and we say, hey, which of these projects is better, the end result, X or Y? Okay. And the answer is, I'm not sure. Okay. Just from a monetary standpoint, just from a net present value standpoint, Y is better. Okay. But X is also less risky. It has a shorter payback period. Okay. And the cash flows come sooner rather than later. That shows up in both the IRR and the payback. Okay. And so it really comes down to understanding what types of projects these are. Yeah. So if both of these were, say, government contracts where you weren't worried a lot about uncertainty, then project Y would obviously be the one you accept because you want more money. Okay. If these were something where there was a lot of variability, then you might want to go with X because X has the shorter payback and has a greater margin of safety shown by the higher IRR. Now I'm going to go back to our example from the other day. And I asked some of you, hey, would you rather give up $1 today and I give you back $1.50 tomorrow, so that's choice G. Or H, give up $10 today, and I give you back $11 tomorrow. So if you look at this, NPV would suggest, because there's no time value of money really in one day, NPV would suggest that project G has an NPV of 50 cents and H has an NPV of $1. And if you just looked at it from a monetary basis, okay, most of you should choose H because you're going to get your $10 back and have $1 left over. So you're better off by $1. That's what net present value is telling you. You got your investment back plus extra money. How much extra money did you get? You're now $1 better off than you were before. Okay. But let's look at the IRR measurement. From an IRR perspective, project G has a 50% return. Project H has a 10% return. Okay. So when you look at it on a percentage basis, notice one of the problems here. Okay. The IRR just provides you with a percentage return, okay, but it ignores what's called a scaling effect. Okay. The fact that project H has a much larger initial investment, and earning 10% off of $10 is a higher net present value than earning 50% off of $1. Okay. But IRR does provide some insight. Remember, I said the higher the IRR, the greater the margin of safety. So IRR is an indicator of the margin of safety. Because look, what if our estimates were wrong? Okay. And the actual cash flows came in at 80% of the forecast. So if actual money came in at 80% of our forecast. So remember, we were making this decision based on what we expected to get back. Okay. What if we actually get back 80% of that? Okay, so 80 times $1.50 means we actually get back $1.20. 80% of this is $8.80. Now look what happens. Okay. Forget about all this. In real life, what happens? Okay. If we only get back 80% of our forecast, G still gives us 20% more than what we started with, but H provides us with $1.20 less than we started with. Okay. So the fact that G had such a high IRR leads me to believe that high IRR is an indicator of a safety margin associated with the project. All right. Any questions on looking at two mutually exclusive projects and using all the things that we've learned about, which is NPV, IRR, payback period, Okay. There's also another one in the book called the profitability index. Okay. And the profitability index is just a ratio. And it's showing you what the net present value is per dollar invested. Okay. And we'll do a couple problems with it, but we don't really use profitability index that much. The two big ones, or the three big ones, are the ones we've talked about. And if you know the three big ones, you'll encounter probably 99% of all capital budgeting conversations if you just understand what the net present value, what the internal rate of return, and the payback period represent. If you can understand those three things, okay, you'll be in the know on about 99% of the conversations. All right. Any questions on those three things? All right, let's go ahead and look at the chapter 8 problems in class. Oh, not those, sorry. Yeah. Let's look at the chapter 8 book questions. All right, so if you look, I'm going to be on page chapter 8 book questions. I'm going to be on page 260. 266. Starting on page 266. So I'll give you a second to find some of those. All right. And so the first question just says, hey, what is the payback period for the following cash flows? So we have an upfront cost at $7,800. We've got $3,100 coming back in year one, $3,200 coming in year two, $2,200 coming in year three, and $1,400 coming in year four. Okay. So we're trying to figure out when it is that we get paid back. And we can see that in year one, we have 3,100. In year two, we have 6,300 if you add these together. And by the time we hit year three, we're at 8,500. So our payback period occurs somewhere after year two, but before year three. So somewhere between year two and year three. So you can kind of see after year two, we've collected $6,300. We need to collect 7,800. So we're short about $1,500. But during year three, we're going to collect $2,200. So you can kind of see we're at 2 years plus part of the way during the third year. So we're at 2.68 years would be our payback period. You can kind of see what's nice is anytime you have things in Excel, it's real easy to calculate different things. You can calculate net present value. You can calculate IRR. And so even though the problem doesn't ask for it, it's pretty easy to calculate the IRR for this problem. And the IRR for this problem would be somewhere around 12%. In fact, it would be 11.82. Find the net present value. You'd have to know a discount rate. If we used, let's say, 6%, you could calculate the net present value pretty easily. And the net present value at 6% would be 928.61. Because we know the IRR at 11.82, the net present value at 13% would be negative. I don't know how negative. But at 13%, the net present value would be negative 167.21. So I know the payback period, real easy to calculate things like IRR and NPV. Even though the problem doesn't ask for it. All right, number 3 says calculate the payback period for each of the 2 projects. So it says Stevenson imposes a payback cutoff of 3 years. If the company has the following 2 projects available, should it accept either of them? So the 2 projects were A and B. Calculate the payback period for A. It was 2.32 years. the payback period for B was like 3.12 years. Okay. But if you looked at NPV, you could kind of see that it might be ridiculous if you just use the payback period. Okay. Because the payback period is going to ignore any of the cash flows after the cutoff period. And of course, project B in year 4 is expected to have $240,000. Okay. So it's going to have a huge net present value. Remember, these are somewhat made up problems. But it's going to have a huge net present value. Okay. But it wouldn't be accepted because it doesn't pay back itself in 3 years. So there are some dangers to just using one approach. And since it's so easy to calculate all three, most people will incorporate all three of these approaches.
If you were to sell a business at year 4, would that count as cash flow?
If you were to sell the business?
Yeah.
Well, I mean, so what happened? Remember what this capital budgeting is. It's kind of like saying, hey, here's what I anticipate will happen. And we'll see it in the next chapter. Okay. So what, or 2 chapters, I can't remember. So what capital budgeting is all about is figuring out what the future cash flows are. Okay. So to do the future cash flows, you're going to have to figure out revenues and costs and depreciation, and you're going to have to do a pro forma income statement and balance sheet. Okay. And what this is basically based on the project's estimates. So people are going to come up with a bunch of estimates of how many units they expect to sell, what's the variable cost, what's the fixed cost. Okay. And that's how you're going to get your future cash flows. Okay. So right now we talk about capital budgeting. We haven't really figured out what the future cash flows are. Once we figure out what they are, they'll start to make more sense. Okay. So right now we're just looking at the tools, NPV, IRR, payback. So really what this is this is an estimate of what you think will happen. Okay. And that's what you're making decisions on. Okay. Should I invest in this new product or not? Should I expand out and come out with a new product? Well, does it make financial sense? Okay. How many do you expect to sell? How many units do you expect to produce? What's your variable cost? What's your fixed cost? Of course, in real life, as you move through time, different things will have an impact on those estimates. Okay. Maybe you were in some kind of business where you were transporting something and you said, hey, the average price of gas is $2.50 a gallon. Okay. And so based on your estimate, maybe you decide to go ahead and this was going to still be profitable at $2.50 a gallon. Okay. To move this stuff from point A to point B. Okay. Well, then it turns out that, you know, today gas is $1.50 a gallon. Okay. Well, in real life, okay, that's going to be a lot lower cost than what you expected, but you couldn't really have anticipated that. So the actual profits may be more than what you expected. Okay. On the other hand, you might be in a business where you expected to sell X number of seats at an event. Okay. And you said, well, based on this history, I expect to sell 200,000 seats, you know, at this event per year. Okay. And then all of a sudden, you know, every month you have so many people coming in to watch some kind of event and you're selling, you know, 10,000 seats one month and 12,000 another and so forth. Yeah. Well, then all of a sudden you have no one coming. Okay. Well, what does that do? Okay. Well, you still made the decision based on the information you had at the time to go forward with the project. Sometimes there will be things that come in unexpected that actually cause profits to go up, and there's other times that they'll go down. Okay. But I mean, that's the hard part. And so what happens is if you sell this business after 3 years, okay, your decision to go ahead with the project has nothing to do with the unexpected event that someone buys your business in 3 years. Okay. Now, if you knew they were going to buy it, okay, then maybe you'd have to estimate that in, but you don't know it will actually occur. Okay. So the project would go ahead and be accepted or unaccepted or denied based on the forecast that you have. It's the best information at the time. Okay. And if you think about something simple, okay, think about something where you're going to take $100 and buy something. Okay. So you look at, maybe you're at a garage sale or something and you say, hey, look at that. There's this piece of equipment, okay, exercise equipment. And I think a lot of people would want this. And I could buy it for $100 and turn around and sell it. And I expect to get 150 back. Okay. That's a pretty easy decision. Yeah. But you don't know what you're going to get in the future for selling something that you buy today. So you have to estimate what it is. Okay. Or maybe you go in and maybe it's a little bit different. Maybe it's something where you can buy 50 items for $100. You say, you know what? If I sell these individually, I can sell them for $3 a piece. Yeah. And if I sell them for $3 a piece, I can buy 50 for $100 and turn around and sell each one for $3 a piece, and I'll make 150. Yeah. That's a good deal, except for what? You got to make sure you can sell all of those. In reality, you might not be able to sell them all for $3 a piece. You might be able to sell some for $3, and then no one wants any more. And then you have to sell some for $2.50 and maybe some for $1. Yeah. And at the end, you decide whether or not that's going to be profitable or not. Depends on what actually happens. Does that kind of make sense? You'll see it more when we figure out where these cash flows come from. Okay. And that's in a later chapter. All right. Everyone figure out how to calculate the 2.68 years? Someone had a question on the Zoom. We okay with the 2.68 years? All right. Let's look at number 5. Number 5 says calculate IRR. Okay. It says you're trying to determine whether or not to expand your business by building a new manufacturing plant. It has the installation cost. Whoops, no, sorry. A firm evaluates all its projects by applying the IRR rule. If the required return is 11%, should the firm accept the following project? Okay. So here's the cash flow, negative 157,300, 74, 87, 46. And they just want you to find the IRR. Okay. Now the question is, should they accept it? Well, if they're only looking at IRR, then they should accept it, okay, because this project's IRR is greater than what they require. Okay. Now, what would be the payback? Let's go back. Someone had a question on the payback, so I'm going to do another. What would be the payback for this project? Well, if we look at it, oops, let me share the screen. I forgot. Okay. So here's the IRR. Okay. Just find the IRR of these cash flows. Okay. And it's greater than 11%, so we should accept it. But let's look back at that payback period. It's super easy, okay, but sometimes if you don't see it, it's difficult. Okay. So you spent $157,300. In year 1, you're expected to get back 74,000. Okay. Just looking at how quickly you get paid back, if you get back 74,000 in year 1, you're still waiting on $83,300 is what you're short before you get paid back. Okay. in year 2, you're expecting to get back $87,000. Okay. So actually you expect to get paid back, if we assume this comes in on a daily or weekly or monthly basis, okay? If we're some restaurant, we might expect this to come in on a daily basis over the year, but we just put it at the year at 87,000. Okay, but it's actually money's coming back in every day. Okay. So we can see that the payback period here is going to be less than 2 years. It's going to be 1 year plus the amount that we're short relative to the amount that we receive in year 2. Okay. So if I look at this, it's really coming back, the payback is really 1.96 years. Okay. All right. Now, we found the IRR at 16.26%. And then problem 6 says, for the cash flows in the previous problem, suppose the firm uses an NPV decision rule. At a required rate of 9%, what is the net present value? Should the firm accept the project? What if the required rate of return was 21%? So again, I already know the answer, sort of. Okay. I just don't know the exact number. Okay. I just don't know the exact number. Okay. But I can put it into my calculator, and 9%, I know because this is my point at which NPV is 0. That's the discount rate that makes the net present value equal to 0. So at 9%, I'll have a positive net present value. And at 21%, I'll have a negative net present value. Now I just plugged this into the calculator, or in my case, plugged it into Excel, but you can use your calculator or something else to figure out NPV and IRR. All right, go ahead and spend a little time on chapter 8, working through the rest of the problems. And what I'm going to do is probably on Thursday, we'll have a quiz over chapter 9. Okay? And I'll post it sometime Thursday. I'll let you ask some questions, but look over these problems, look over the homework problems, look over how to find NPV and IRR and payback period. What's that?
You mean quiz over chapter 8?
Yeah, what did I say? Chapter 9? Yeah, sorry. Yeah, chapter 8. Okay. So look over these problems, make sure you know how to calculate, and then on Thursday, we'll finish up a couple more problems, and then we'll probably be done. We'll be done with this chapter, but you can ask me some questions once you've had a chance to work on the problems, and then we'll have a quiz on Thursday that'll probably be due Friday over chapter 8. Okay. But I'll give you some time to work through and ask me some questions. All right. Anything else?
Oh, I have a question.
Mm-hmm.
So for our final, when we have our final exam, is it going to be comprehensive?
No.
Okay.
Okay, but it will be, you'll see when we get to these other chapters that we're going to reuse a lot of the same stuff we've learned. Okay, so we haven't figured it out yet, but the answer is no. But actually, it's semi-comprehensive because to find the weighted average cost of capital, which is a later chapter, you'll have to find the cost of debt. So you'll have to find the yield to maturity on bonds, and you'll have to find the cost of equity. So we can go back and look at some of those earlier chapters. But you already should know how to do it. So the answer is no, but there is sort of a hidden agenda in there that some of the stuff that we cover over the last test actually is somewhat comprehensive in nature. So, but the answer to the question is no.
All right, thank you.
All right. Well, I'll see you guys on Thursday then.